Okay, good morning. Welcome to a short video about the NumberPhile video on Graham's number. They just put these videos out yesterday, and they have an interview with Graham himself. It's absolutely amazing, and I'll link them in the blog post, and you should watch these videos. There is unfortunately one little mistake that I just want to correct because Graham's number is actually bigger than what they say in the video. So. And the reason I wanted to do this by video is it's easier to write out this notation than try to type it in a blog post. So if you go back and watch the videos or read Evelyn Lamb's blog post or whatever it is, you can see the procedure for constructing Graham's number, and Graham explains the thing where this procedure came from in the NumberPhile videos. So you start with 3, then you go to something called 3 up arrow 3, which is 3 cubed or 27. Then you go to 3 up arrow 3, which turns out to be 3 to the 27th, which is about 7.6 trillion. And now next you go to 3 with 3 up arrows, 3 up arrow 3, which is 3 with 7.6 trillion powers of 3 sort of going up to the top. And then once you have this number, now you get to the start of Graham's number, G1, which is 4 up arrows, G2, which has G1 up arrows, and you repeat this 64 times, and then you get Graham's number. So it's very difficult to even think about or understand, but the thing in the NumberPhile video that I want to talk about is their computation here of 3 up arrow 3. So they say that this number, 3 up arrow 3, is, let's see, 1.25 times 10 to the 3.6 trillion, about. And that, unfortunately, is not correct. That number that they wrote down is 3 to the 3 to the 3 to the 3. So 4 3s in the tower, not 7.6 trillion 3s in the tower. And to be fair to NumberPhile, it took me about a week when I was going through all these things, learning about Graham's number, to understand all this notation. So it's very easy to get tripped up. You're not used to dealing with numbers that are this big, nor do you think that 4 3s in a tower is going to be a number this big. Now, one of the amazing things about Graham's number is how big it is, and you'll see on the Wikipedia entry they say Graham's number is so big that even if you took the size of the observable universe, and put the one digit in each Planck volume, you wouldn't be able to write the number down. Now, the size of the universe, according to Wolfram Alpha, is about 4 times 10 to the 80th meters cubed. A Planck length is about, I think, 1.6 times 10 to the minus 35 meters cubed. So if I take the size of the universe and I just pretend to look at a Planck cube divided by the Planck cube, I get something like, I wrote it down, 8.5 times 10 to the 184. That's how many Planck volumes I have. Now you can see with 3 to the 3 to the 3 to the 3, which is 1.25 times 10 to the 3.6 trillion, I've got 3.6 trillion digits. So here I've got enough room in the universe to write this number down. But the next one, 3 to the 3 to the 3 to the 3 to the 3, with 5 3s in the tower, I don't. So already, if I cut this number off, instead of having 7.6 trillion 3s tall, if I cut it off at 5 3s, I'm already bigger. I already have a number that's too big. I can't write it down if I use the Planck length, a volume, a unit cube of Planck length, to write down each digit. And that's with 5 3s in the tower. And I've got 7.6 trillion 3s in the tower. And that's the step before I get to G1. So already with 5 3s tall, it's a number that's too big to even understand. Well, not totally true. It's actually fun to try to think about how big this number is, but it actually has more digits than 8.5 times 10 to the 184 by quite a bit, actually. So in fact, it has about half this number digits. Anyway, so that's the little mistake I wanted to correct, that 3 to the up arrow 3 is not 1.25 times 10 to the 3.6 trillion. It's so much vastly larger than that. that 1.25 times 10 to the 3.6 trillion is just 4 threes. Even at 5 threes, it becomes very difficult to even try to figure out what we're talking about. 7.6 trillion threes tall, forget it. You can't. There's no way to even think about it. And then you get to the 4 up arrows, and then you go to Graham's number. So watch the NumberPhile video interviews with Graham. They're amazing, and just realize that because of this little mistake they made in the video, Graham's number is actually bigger than they say it is, which is kind of funny.